Over the last few episodes, we made plain vector RAG about as good as it gets. Clean chunks, lightning-fast search, a sharp re-ranker putting the best passages on top. And for most questions, that is genuinely all you need. But vector RAG has a ceiling, and it is not a bug you can tune away. It is baked into how the technique works. At its core, it finds passages similar to your question. That is perfect when the answer sits in one passage. What does our refund policy say? One chunk answers it, done. But there are two whole kinds of question where that approach quietly falls apart, no matter how perfectly you chunk or re-rank. Today we look at those two failures and the different shape of tool that solves them. The knowledge graph. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. Here's the whole idea in one sentence. GraphRAG as a form of retrieval augmented generation that first organizes your documents into a knowledge graph of entities and the relationships between them, then retrieves over that connected structure. So the model can answer questions that require linking many facts rather than matching a single passage. To feel why you would ever need that, let us look hard at the two questions plain vectors cannot handle. The first is the multi-hop question, the kind where the answer is a chain. Imagine asking which engineer who worked on Project Atlas later went on to lead a team in Berlin. Stop and notice, there is probably no single chunk anywhere in your documents that contains that whole answer. One document lists who worked on Atlas. A totally different document, maybe written years later, mentions who leads the Berlin team. The answer only exists in the link between them. Vector search will dutifully fetch chunks about Atlas or chunks about Berlin, but it has no way to walk from one fact to the next because it matches on similarity and it cannot follow a trail. The connection is invisible to it. The second is the global question, the kind that is about everything at once. What are the main themes across all of these reports? There is no single most similar passage to that question because the answer is not in any one place, it is in the whole collection. And remember, vector RAG only ever grabs the top handful of chunks. So it pulls a few passages and tries to summarize from them, missing the forest entirely while staring at 5 trees. Ask it to count, to compare across the whole set, or to summarize broadly, and top few retrieval simply cannot assemble that view. GraphRAG fixes both by changing what you store. Instead of just a pile of chunk vectors, you build a knowledge graph. You use a language model to read through your documents and pull out the entities, the people, companies, projects, and concepts as nodes and the relationships between them worked on, located in, reports to, acquired by, as the links connecting those nodes. Now your knowledge is not a heap of separate passages, it is a connected web of facts. And once your knowledge has that shape, retrieval changes shape too. For a multi-hop question, you can traverse the graph, start at the Atlas node, follow the worked-on links to the people, then follow those people to their current teams. And the chain you needed is now literally a path you can walk. For a global question, the leading approach from Microsoft's GraphRAG project groups the graph into communities of tightly related entities, uses a language model to write a summary of each community ahead of time, and then answers a broad question by combining those community summaries. That gives you a genuine view of the whole corpus, the themes across everything, which top few retrieval could never build. Let us name the real tools, as the brief demands. Microsoft GraphRAG is the open source project that popularized this whole approach, the pipeline of extracting entities and relationships and then building those community summaries for global questions. And Neo4j is the best-known graph database, the place the extracted graph often lives and gets queried using its own query language called Cypher. And in practice, many real systems are hybrid. They keep the vectors for find me the relevant passage, and add the graph for connect these facts and summarize across them, using each where it is strong. Now the honest trade-offs, because GraphRAG is not a free upgrade. Building that graph is expensive. You are running a language model across your entire collection of documents just to extract all the entities and relationships, and then again to write all those community summaries, which costs real money and real time. Far more than simply dropping chunks into a vector store. It is also more moving parts to maintain. So GraphRAG is genuine overkill when your users only ever ask simple, look-it-up questions, the kind of plain vector RAG already nails. The rule of thumb, reach for GraphRAG when the value of your data lives in the connections between facts, not in the facts sitting in isolation. So how does this land depending on who you are? As an individual, you mostly meet this through products, the research and analysis tools that can see across an entire library and reason about it, rather than answering one isolated question at a time. As a startup, the advice is clear. Do not start here. Start with plain vector RAG, and only add a graph once you notice your users keep asking questions that span across documents, and your system keeps failing them. And as a large enterprise, this is exactly where GraphRAG earns its cost, connecting knowledge scattered across a giant organization, where the most valuable answers live in relationships that no single document ever states out loud. So let us bring it home. Plain vector RAG retrieves passages similar to your question, which is perfect for single passage answers, but blind to two things: multi-hop questions, whose answer is a chain across documents, and global questions whose answer is the whole collection. GraphRAG fixes both by turning your documents into a knowledge graph of entities and relationships, so you can traverse connections and summarize communities with tools like Microsoft GraphRAG and the Neo4j database, at the cost of more time and money to build. Now, notice the quiet shift happening across this whole part of the course. Retrieval started as one fixed lookup, and it has been growing up until now we are choosing the right retrieval structure for the shape of the question. The natural next step is to stop deciding that in advance ourselves and let the AI decide for itself. Search, look at what came back, reason about whether it is enough, and search again if it is not. When retrieval becomes a loop the model itself controls, you have Agentic RAG, and that is exactly where we go next. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.